Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to deal with one of the problems which we encounter while we are working with our academics, that is splitting a circular linked list into two halves. Let's go through that problem. Let's understand what a linked list is, circular linked list is, and an animation on the same, how to divide them. With the help of Python code, we'll resolve this problem. Let's start. Circular linked list. Generally, a linked list is a linear data structure where the data is not stored in contiguous memory locations. Means one data element is related to only a single piece of another data element, but these two elements are not placed in contiguous memory locations. They'll be scattered throughout the memory. Then how they are going to relate each other? With the help of addresses. So here, every data is going to have another part attached to it, which is nothing but a link part we say, and which stores the address of the next node, right? So that will become a simple single linked list on the first node. Then it looks like in this way, every piece is a node in itself, right? So in this way, you can see that this is a simple single linked list where it is the first node, second node, and third node. All three nodes are arranged in such a way that each node holds a data part, and in the address part, the link part, it holds the address of its next node. Whereas the third node over here is the last node, so its next part, that is the link or address part, will hold either none or null to specify that there is no node after it. There is a drawback in single linked list. The major drawback is when we work with it, say for example, we are working with the single linked list and you are at node number 3. Right now you are node number 3 and you want to access the element which is present in node 1. So in that cases, you have to restart the whole process with the start or the head node, fetching the address of the first node and start the process once again. So to overcome that, a simple solution will be storing the address of the first node in the last node, which says that the third node is going to say that the next node to me is the first node. If we can bring a chain structure to that, then we can say that one of the problems of a single linked list can be overcome, right? So we all know that single linked list run in unidirection. So as it runs in a unidirection, you cannot come back to your previous element because every node stores the address of the next node, but not the node which is behind it, right? So coming to this cyclic structure is nothing but your circular linked list. So the def goes like this. A circular linked list is a sequence of elements in which every element has a link to its next element in that sequence, and the last element has the link to the first element, right? So this is the basic def of circular linked list. So this is how it is going to look like. Have a look at the picture which I have given you guys, which have addresses in it. Okay, you can clearly see that the last node 23 is holding an address 2000 and saying that my next node is at 2000, whereas the node at 2000 is nothing but the first node. This is nothing but your circular linked list. So how to work with the circular linked list? With the help of Python code, I'll be giving you a small demo on the same. Okay, so as I said, the building block of linked list is nothing but a node. So let's see the constructor of a node. As Python is an object-oriented programming language, I would like to take the leverage of the class concepts over here, right? So I'm going to create a class named node, in which in its constructor I'm going to take two parameters. One is the next part and the first is the data part. So have a look at this one. So this is the new node, right? So in which the data part is going to get the value from the parameter itself, whereas the next part is filled with none. Why none? Because when we create a node, this node is not related to any other node or nothing. It is a newborn one. We have to build the relations. If we store address of any node in the next part, overwriting the content this none, then we are establishing a relation between this new node and that node with which you are relating this node to, right? So on the first hand, the next part will be filled with none. So this is how we are going to create a node, right? Coming to the next class, which is a circular linker list class. So what it consists of? Basically, it consists of a start pointer. The linker lists have many advantages. Dynamically, we can create the data points with insertion, deletion, search operations are very easy. Everything is very easy, but its basic limitation is as it does not have any index values. As the data is not stored in contiguous memory locations, we cannot assign index values to the node, just like we assign index values to the values present in an array, right? So that is the basic flaw in a linked list. As we do not have any index values, whatever the operation you want to perform, whether it is an insertion operation, deletion operation, search, reversing, any operation you take, you have to start the work from the first node. And whatever the type of linked list it may be, whether it is a single linked list, circular linked list, or a double linked list, whatever the list it may be, we have to start the process from the first node. So the gist of the story is, we at the beginning we have just the address of the first node in a pointer variable. That pointer variable is nothing but the start. Start is the variable which holds the address of the first node, right? So initially the list is not created. So I have taken the start node and I've filled it with none, saying that just if the start pointer holds none is it's filled with none, we can say that the linked list is empty right now. Only if you build a relation, you can see or start pointer is going to hold the address of the first node, right? That is one of the first members in my constructor of CList. Next one is CTR. CTR is nothing but a variable, just a count variable to get the count of or to hold the count of number of nodes, that is the number of data values present in my circular linked list. So after insertions, each and every insertion, the count will be incremented. With every deletion, the count will be decremented. Am I right? Count will be either incremented or decremented. At any snapshot of point, if you want to know the number of data values present in your list, then by just retrieving the content in this variable CTR, that is the counter variable, you can get the number of nodes in the list. For that purpose, I am maintaining the count in the variable CTR. This is the basic structure of our circular linked list. Okay, right. Let's construct a circular linked list. Our job, the main task over here is to split the circular linked list into two halves, right? Very good. To split, we need to create it first, right? So with the help of inserting at the end, that is with the help of, you can simply say append operation. Okay, inserting at the end by default, that is append operation. I'm going to give the demo of the same, right? So let's start. So first of all, take an object of class node and its name is node, and whatever the data you are going to pass to it, with the help of that, it is going to create a node. Here I have two cases. A case where the circular linked list is not yet created, and whatever the node which you have taken is the first node of its kind. Or you have handful of elements and you're trying to insert another element, that is you're trying to append an element, right? So these are two different cases, my dear. So let's start with the first case where the circular linked list is not yet created itself. So that is if the start pointer is holding none. If the start pointer is holding none, then we can clearly say that there is no list yet created, been started. Whatever the node you have declared now will be the first node, right? So I'm going to store the address of the node in the start, specifying that I'm the first node, right? The second point, as it is a circular linked list, as this is the first node, the next node to it will be itself, right? It is cyclic. The last node holds the address of the first node. But here, the first as well as the last node is itself, the first node itself, right? Even the last node is the same. So it is going to hold its own address. For that purpose, at the first, in whenever we start creating a circular linked list, the first node when we create, it will hold its own address in the next. Okay, well and good. The second is a case where you have handful of elements, as I said. So as I am trying to go for append operation, I have to reach the last node first, right? So to reach the last node, what is the beauty of circular linked list? The last node will hold the address of the first node. Very good. Have to compare the same. Who is holding the address of the first node? The start. The start pointer is holding the address of the first node. Very simple. Job done. Give the name temp to the first node and you take the hops until unless you reach a node whose next is equal to the start, right? So you are going to keep on hopping from one node to the other node until unless you reach the last node. Once you reach the last node, store the address of the node which you have created in temporary next, and as as I have said, I'm going to append, insert it to the last. So self start the first node's address in the node next part you are going to store. Try to understand this, guys. These two lines, the last two lines. Once you reach the last node, store the address of the new node in temporary node's next part and the first node's address in a new node's next part. Okay? Do not worry. Through animation, I'm going to explain you the same. As this is an insertion, append is also an insertion. By default, when we insert at the last, without even specifying the position, we call it as an append, right? So as I'm increasing the count or the number of node in a linked list, I'm going to increment the counter, right? So this is the last point, right? Well and good. So this is how I'm going to create my circular linked list. Have a look at this one. Initially, the start is none and I have created a node. Very good. Whose data part is 20. Next part is none initially and it is located at location 5000. So once I create a node and I see that the start is holding none, which means that there is no node yet created, I have to build a relation between these two. So have a look. So very simple. In the start pointer, I'm going to store the address of the node, and in the node's next part, I'm going to store its own address, right, which is 5000. This is how it is going to look like now. Now the start pointer is holding the address of the node, which is 5000, and the node's next part, which was previously none, is overwritten by its own address 5000. Say no, now node is saying that I am at location 5000 and even my next node is at location 5000. Means I am pointing myself, right? This is case 1. Let's go to case 2. Have a look at this one. This is the node which I am talking about. This I have to append in the last. That is, initially my list is looking like this: 21, 22, and the 22 is pointing to 21, saying that my next node is 21. Now I have to append it. So after 20, I have to insert 22, I have to insert 20, and 20 must say that my next node is 20. This is the job I'm supposed to do. To accomplish this task, I'm going to name the first node as temp. And I'm going to take the hops until unless I reach the node whose next part is the first node's address. Very simple. So I have taken hops, and with the second hop I can see that the next part of temporary is nothing but the first node's address, which is 5000, right? Once I reach this case, I'm going to append. How? By storing the nodes, the new node's address in temporary next. And second step, by storing the first node's address in the node's next part. 5000. Now, can you see a circular linked list created over here? Have a look at this one, my dears. Have a look at this one. So 21 is saying that my next node is 22, 22 is saying that my next node is 20, and 20 is saying that my next node is 21. It is cyclic in nature, right? And even you can see that here the last node over here is 20, right? And it is holding an address which says that my next node is the first node. That is the basic funda of circle linked list, which is accomplished. I hope you understood. Please go through these addresses, guys. It will be quite comfortable for you to understand linked list. Only if you represent them using addresses. When we work with linked list, addresses plays a vital role rather than the data. Right? Because data at any point of time we can change. But the links which should not miss for that purpose. Right? Very good. Now you have learned how to create a node, how to start with the constructor of a linked list, and how to create a linked list. Now the basic problem which I'm going to address now, which is breaking the circular linked list into two halves. Right? Well and good. So I need, see, I'm going to break it in such a way that there will be two resultant lists in such a way that the first list will be a part of the initial given list itself, and the second list will hold the remaining elements, the other half of the elements. For that purpose, I'm going to take two pointer variables, which is previous and temporary. Here I get two cases. A case where there is no list, that is, circular list is not yet been created. If it is not created, then there is no point in dividing it into two pieces, right? Very good. So if I'm going to check it with the content in this tag. If it is none, just return. Or you can give a user-friendly statement also over here saying that the list does not exist, right? If this is not the case, you have handful of elements, then use this while loop where I'm going to check temporary next is not start, which means that you are not at the last node, and temporary next is also not the start, that is the last two nodes, right? In that case, you build this relation. You are going to swap you are going to override the content in the temporary and previous pointer variables. right? Then you are going to make two lists. Okay, stat 1 and stat 2. Stat 1 and stat 2 are the two objects of the same class circular linked list which will help you to create, right? So this is the function of a circle, breaking a circular linked list into two halves. If you look at an animation of the same, have a look. This is the circular linked list. Have a look at this one briefly. There are four nodes, 21, 22, 23 and 24, where 24 is again pointing to the first element 21. The first list will be in such a way that it will hold the address of the first node only. So start and stat 1 are the same. Whereas the second half of the list is a new beginning. It will hold the address of the first node of second half. Have a look. The second half starts with the node 23. Am I right? It starts with the address node of whose data is 23 and its location is 7000. So the start 2 will hold the value 7000. Right? So have a look at this one. You have two half circular linked list where these two halves still hold the property of circular linked list nature, right? So this is a brief note on how to create a circular linked list and how to break them into two halves. Let's implement the same using Python. Yes, welcome back guys. Here we are in the environment of Python. Here I'm going to write the code for circular linked list, breaking them into two halves, right? So let me first of all create it, then I'll break it, right? Let me open the script for the same. Yes, this is the script where I'm going to write the code. So initially, I'll write a user-friendly statement, that is a comment line saying why I have written this code for, right? Generally, whenever a novice opens this code, must be able to understand what is the functionality of this code, right? So for that sake, I'm going to put a comment line first of all saying split the circular linked list into two halves, right? This is my task. Let's start. Generally, whenever I start the task, I start with my driver code. I just want to be clear with what are the inputs in my hands, what are the functions which I'm supposed to call, and all. Whether it can be using the object oriented concepts, which is class, or without classes, just a simple few functions, whatever the task it may be. But I just want to know what are the input values, what are the functions that I'm going to call, and what output I'm going to get. Whether I'm going to display the output or project the output from the function itself or from the driver code. Everything I'm going to decide when I write my driver code. Taking driver code as my backbone, I am going to build the bodies of the functions, right? So let's start writing the driver code first. Yes, this is the place where I'm going to write the driver code. So as we all know that linked list, we have to work with classes. So let me take a class first. So let me create an object for the same. As I'm going to work with the circular linked list, I'm going to name the object also as a CLL, right? So circular LL. So circular LL is the name of my class, and CLL is the object of the same, right? Very good. Now there is a clear picture in my mind that I have to create a class with the name circular LL. Very good. Then when I split this linked list into two halves, that means the resultant two are also circular linked list only, right? So as they are also two circular linked lists, I have to create two more objects to specify them. Very good. CLL1 is nothing but is a circular linked list, and CLL2 is also circular linked list. So I have totally created 3 objects: circular linked list 1 and circular linked list 2. Right? These two are going to hold my guys, I think yes, circular linked lists 1, 2 and 3. CLL is the object which is going to hold my basic given or red circle linked list, and the resultants are circle list 1 and 2. Very good. So now, first of all, let me create a circular linked list. For that, I need to decide how many number of nodes it is going to have. Right? Very good. So let n be that variable. So n is that variable. Enter the number of elements in your CLL. So how many number of elements you want in your circle linked list? Once you decide that, now create the same. So for I in range of n, those many nodes you are going to create. So CLL dot create. Enter the value which you want to insert into it, right? Enter a value with which you are going to create. So this is how I'm going to create my circular linked list. Well and good. Once I create my circular linked list, I would love to see it, how it looks like. So for that sake, I have to write a display function also, right? So print /n original CLL, how it looks like. So for that, CLL dot display, let display be the function which will help me to get the display of or to see my circular linked list which I have created just now. Well and good. Now I have to go for major task. I have to call the function which is going to split this circular linked list into 2 halves. Very good. Let's name it as its a job is to break into 2 halves, split. And what you are going to break? Circular linked list. So one second, with the help of object, I am going to do that. Split CLL. And what are the parameters I am going to pass to it? Very simple. The objects of the the remaining 2 objects which I have created, which are going to hold the resultant 2 lists, the first half and the second half, 2 halves, right? So CLL1, CLL2. Let the 2 parameters be CLL1 and CLL2, the 2 objects. Okay, so there goes the basic function. Once this function call gets raised, then they are going to get splitted into 2 halves, where the first list CLL1 is going to hold and the second list CLL2 object is going to hold. Let me display the same to see how they got broken up, right? So print first list, right? So CLL1 dot display, and this next second statement will be second list. Guys, if you want, you can write more precisely saying that the first half of the given circle linked list. They are user friendly statements, my dear. You can write as you wish. CLL2 dot display. Okay, so let's look at this driver code. I have taken an object of circular linked list class and I have created it by reading the number of nodes that I want in it. Then I have created two objects of the same class, and I have using the function split CLL, I'm going to break them into two halves, and the objects of the corresponding two halves I have passed as parameters. So have a look at this one. I have to go for writing the create function, display function, and the split function. These are the three main functions. And on the background, I'll be needing the constructors and the classes, right? So let's start the same. So I have a rough sketch in my mind. What are all the things I need currently, right? So class, let me give some space so that you can understand. Class node is the first one, whose constructor will be self and data, right? So self data is going to hold the data part, whereas self next is going to hold none, first of all, specifying that there is no node yet been created, right? So the next one will be, what is the name which we have given? Circular LL, right? Yes, this is the name of my class, right? Let's go with the constructor of the same. Self, right? So self dot stat is equal to, guys, in many books you might have seen it is head or stat. They are the names of the variables, guys. Even I can write my name over there, right? Just give relevant name. If you feel that it is the head which holds the address of the first node, fine, you go with the terminology of head. I'm used to use the variable as it starts with the first node, the start keyword. That strike my mind. So I use the variable name as start. It's your wish. Don't get confused. Both are same. They are mere variables. They can be named as you like. They're just identifiers. Okay, fine. I've written the constructor for the same. Let me write the function to create. Right. Create. And in the driver code, you might have seen that to the create function, I have passed the data which is going to get filled in. Right. So I have taken an argument over here. So what is the precaution I have to take? The basic precaution which I have to take is I have to check whether circular linked list is existing or not. If it is existing, well and good. If it is not existing, this node will be the first node. Very good. So to create the same, I'm going to create the node first of all. That means I'm going to take an instance of the class node and I'll pass the value data to this. Thereby a node is created. Well and good. Now I'm going to check if my start is none or not. If it is none, you are going to do some other task. If it is not none, then you are going to append two different jobs, right? So before that, let me take, very simple, let me give a name temporary to my self start and let the new node next part be self start. Okay, so I have named the the node as start as temporary, and the new node's next part is filled with itself. As I said, first node, what we are going to do to fill it with itself. Very good. Then, if self start is not none, let me go with that case. If it is not none, then what I'm going to do? As I have to hop till the end, right? So temp dot next not equal to self start until unless I reach the last node, I'm going to take the hops. Temp dot next. So once I reach the last node or a node whose next element is the first node itself, there I'm going to append. Right. This is how I'm going to append. New node's address stored in the temporary next part. That is the link part. else. It is a case where there is no list yet been created. This is the first node. Then new node dot next is equal to new node. So it is going to hold its own address, right? This is the else part. So whatever the case it may be, the self start will hold the address of new node as I'm going with the append style of in creating a circular linked list. Very good. Creation is done. Now my next task is to split them into two halves. Let's do the same. What is the name I have given? Let me check my driver code once. I have given the name as split CLL. I have to use the same terminology, guys. I hope you remember the rules. Split CLL. So, what are the parameters it is taking? It is taking the objects. Two objects which represents two halves of the given circle linked list. Let me take the same. Self list 1, list 2. These are the two variables I'm going to use. Okay, right. Then I have to initialize or I have to give a name to the first node, which is previous as well as temporary. As these two are going to help me out while partitioning, right? So if the precaution I'm going to take, my dears, what if my start is filled with none? That is, list is not yet created. Then simply print saying that CLL is empty and return. There ends the story. If it is not the case, start is having some address in its hand. That means there are a handful of nodes. Now let's begin the process of splitting. Right. So while temp next is not equal to self start, that is you're not at a node which is the last node, and temp next, which means you're talking about a node which is an alternate to next to next, right? A neighbor to the neighbor. Node is also not your first node, right? That means wherever temp is standing, its next two consecutive nodes are not the first node. They are not pointing to the first node. In that case, temp is equal to temp next. You are taking a huge hops, my dear. Previous next. That's a long jump you are taking. Temporary is taking two hops at a time, whereas previous is just taking one hop, which literally means that any node whose name is temporary, then a node which is just behind it will have the name previous. Okay, so wherever temporary takes two hops, previous will take a single hop. Very good. So once you reach when one of the conditions fails, then if this can break in two different cases. If the temporary next node is the first node or the next node, that is, it depends upon even number of nodes and odd number of nodes, right? So I'm in the while loop I'm covering both, even if the list is of even count or odd count. Good. If temp next is self start, that is, it's a alternate element. It is the case where the number of elements in your list are even in count, right? So take a single hop so that you can break it now, right? I have taken a single hop. Then now I'm going to start my list 1 and I'm going to assign it with this name. So whatever the address of the start is there, it is passed to the first list address field, right? Now I have to go with the second list. So if self start next element is not equal to self start, then I'll start building my second list. Okay, so with this I have split that. You have broken that pieces into two halves, right? So now I have created list 1 as well as list 2. Then temporary next will be filled with the previous next, and the previous next is filled with the self start, right? So with this piece of code, I hope you are able to understand how I have broken it. So I have, with the help of the number of nodes, the temporary and previous pointer variables, I have worked it. Okay, so I have split the list into two halves. Okay, job done. But one of the major tasks is yet to be finished, and that task is display function, I guess. Whether you create, you split, whatever you do, it is happening internally. How would you know how what's happening inside it? Only when you display it, you'll understand it. So let's write the same function. So display self, starting with the first node. Guys, you can go with many kinds, like if the self start is equal to none, just display saying that circular list is not yet created or empty. Any user friendly statement you can give. But I'm starting keeping in mind that yes, list is created. Okay, and I'm naming the first node as temporary because it's a linked list. I don't have index values to directly go to whatever node I want to work with, right? I have to start with the first node, whatever the task it may be, right? So I have named it as, right, I have named it as temporary initially. If self start is not none, very good. That means the list is existing, right? Then while true, while true, print the data. Percentage temp dot data. Okay, so I'm going to print the data and I'm going to take a hop. Temp is equal to temp next. So till when I'm going to do that? Until unless my temporary is holding the start address, which says that it is the last node. If temporary is going to hold the address of the first node, then I can say that my job is done. Just break, come out of the loop. Displaying is done. Okay, so this is my simple display function, my dears. So let's have a look at the code which we have written. I've taken a node class and I've written a constructor for the same. I've taken a circular linked list class. I've written the constructor, then a create function to create a linked list, then split function to break the circular linked list into two halves, then a display function to print the same. With my circular linked list driver code going hand in hand, right? So I hope this is quite clear. Let me save this and run it. So let me give a reasonable name to it, which is split CLL. Okay, let me compile the same. So it is asking me enter the number of elements in your circular linked list. Let me give a value 5. Let me take 5 values now. 3, 4, and 5. These are the 5. And the elements in your list are very good. The original list is saying that it is having 5, 4, 3, 2, 1, and its first list is having elements 5, 4, 3, and the second list is having elements 2 and 1. As let me maximize my screen. Okay, I hope now you can see quite clearly, right? So this is how I'm going to split my circular linked list into two halves. So if you want me to go for another run with even number, the same point, right? So even you can work with the even number also, right? Let me do the same. Yes. Okay, let me maximize this one. Yes. Let the number of nodes be 6. Enough. So the elements are 1, 2, 3, 4, 5, and 6. Enough. They are split into two halves. 6, 5, 4 are in the first list, and 3, 2, 1 are in the second list. I hope this program is quite clear for you. Please go through the main heart function of this task, which is split CLL. Guys, if you want, you can write or make a habit of writing comment lines with every function definition, saying what is the purpose of this particular function, right? Like split CLL, the function name is self-explanatory, but still you can write split the CLL into two halves. You can write the comment lines, and they are very helpful also, right? So this is a program using linker list, breaking a circle linker list into two halves. Do follow our channel, guys. We have many videos on circular linker list and how to work with the single linker list, reversing the single linker list, double linker list, and many more. I hope you understood today's topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.